All right, so this is the graph of a function. We want to choose the graph of its derivative from the following. All right, I'll scroll down and get to it in just a second. But a couple things that we can deduce right from the start. So first off, the graph of a function, you may not know exactly how it's going to relate to its derivative, but there are things that you can count on. So wherever a function has a minimum or a maximum, which this one's kind of off scale, but that's okay. Wherever you have a minimum or a maximum, your derivative is going to be 0, okay? Because that's just a principle. So critical numbers occur where the first derivative is equal to 0, and that's where we have relative extrema. So right away, we know that we should have -2 and +2 as zeros. So looking at the possible graphs here, this first one's out because it doesn't have the zeros at -2 or +2, so that's not an option. And this one's out as well, so here and here, so we can throw that out. The remaining two do have zeros at -2 and +2, but the difference is where the graph is above 0 or below 0. So let's go back to the original graph and some properties and trying to determine that. All right, so the first derivative is going to be bigger than 0 whenever the original function is increasing. And the first derivative is going to be less than 0 whenever the original function is decreasing. So if you'll notice here, I'm increasing on this interval. So we're increasing from -∞ to -2, and then we're increasing again over here on this interval, so from 2 to +∞. And then I'm decreasing in value on this interval, so I'm decreasing from -2 to +2. So I need to determine which of those matches that. And I'm not going to be looking to where the graph itself is increasing or decreasing. I'm going to be looking to where, so this is where the function is increasing, so that should be where the first derivative is bigger than 0. So if I look at this first option, this part of the graph, the derivative is bigger than 0. And this part as well. So what that means is the function would be increasing on those intervals. So that matches up. Over here, it doesn't match up because on this interval and this interval, the first derivative is less than 0. So the function should be decreasing. So we can throw that out, and that leaves us this last one as our correct option. And that's the kind of thinking that we need to do in order to determine something like that.